Okay, welcome to Chapter 11. Chapter 11, does that mean we're going bankrupt? Okay. So page 417 talk about implementing. So we've got a plan, we've spent, getting ready to spend some money, and now we need to install whatever, IDS or something. The learning objectives is, transition from a blueprint to an honest-to-God plan. What's the role of the project manager, that kind of stuff. And do I actually need professional project management for this thing? And, and technical strategies and models, yeah. But the organizational considerations, yeah, that number 2 there, ooh, that's a tough one. You really need to know your audience before you can do these things. And again, there's going to be some technical and non-technical problems that are going to show up. Okay, the opening case, they're doing a meeting, a change management meeting. And, he was surprised to see an awful lot of details, like, wow, several, hundreds of pages worth of stuff. And people were going, wait a minute now, you expect me to do homework before I come to this thing? It was, again, the organizational thing. Didn't quite understand the burden they were putting on the members of the team. Expected them to say, well, of course you've read through this, and of course you're ready to talk about it, and we're ready to go. And everybody went, what? Okay. So, introduction to information system implementation, page 418. So this is like anything else. If you're building a house or building a bridge or installing a new firewall, it's all the same. You go through the exact same steps every single time for any type of project. By the way, we have a really cool IS project management class. Excellent class. I would recommend that for every single student, regardless of their discipline, because project management is a specific skill. And man, if you're known to be good at that, then you're going to end up getting projects when you go to work. Yeah, good stuff. Okay. So most do not try to develop their own proprietary system because there's enough out there. There's tons of research of people doing this for a living and have come up with the ideas of here's how you really ought to do it. Now, there's lots of choices, and some of the choices are kind of counter to some of the other choices, but that's okay. So here's some examples. One of them is called RAD, Rapid Application Development. Basically, we're talking about using some fancy tools that do an awful lot of particularly for the graphical user interface, the GUI. Like it'll automatically design this thing for you. You could scoot things around. It's rapid development, and you look at it and play with it, and that kind of stuff. JAD is Joint Application Development. Basically, you don't just have a team of programmers working on this. You have the users on the staff that are there. Now, they may be looking over your shoulder and not understanding a thing that you're typing. But when it comes to, but wait, you only left this much for this code, and sometimes the data is this much, and you go, so you stretch the field out on the graphical user interface, because how would you know, right? Okay. Agile. Now, Agile is kind of it's not exactly new, but it's one of those feel-good type things. We're going to use Agile, and that works pretty decent under certain circumstances. If you have no particular timeline and you got a lot of money, well then great, go ahead and use Agile, because Agile will allow you to to go off down a path and go, ooh, that didn't work. Let me back up. Okay, we're going to go down this path now. And changes kind of happen all along, and there's no real documentation of what's going on, and you just hope that at the end you've had enough feedback from the users that you end up with a decent product. Now, sometimes that works fantastic. And other times it's like, look, we have to implement this. This product has to be done before the merger in June. Okay, that kind of stuff. Agile is not a good choice if you're under very strict timelines or very strict budget, because Agile is all loosey-goosey, and I can change my mind and chase after phantoms. DevOps is a term. Basically, what that means is instead of having a separate development team and operations team, you combine them together into one organization. And it's kind of more of a philosophy than an organizational chart change. Basically, what it means is there's no more finger pointing. I mean, you can't say, well, it worked in development, so if it's broke now, you must have done something. And the people who are operating the system say, but no, you designed it wrong. Just a lot of finger pointing. And so having them all work for the same company, same organization with the same boss, kind of solves that problem. Okay, the system development lifecycle, page 419. So this is a technique that you use, again, for building a house or moving your infrastructure to the cloud. Doesn't matter what the project is. This is the steps that you can use. Now, this is different than Agile. We talked about Agile briefly, but I'm going to move on from that. Not that this is really relevant, but I'm not a fan of Agile, okay? Just telling you. Okay, so the SDLC, it's a programming methodology, and it allows for easy tracking of the progress. You throw a Gantt chart, we'll talk about what that means. A Gantt chart up on the screen, you say, we're right here, we're 42% done in this task, and we're 18% done in this task, and it looks like we're going to meet our goals. Okay, so this thing we're talking about, this is typically what's called a waterfall, and you can kind of see how it works. I do an investigation, and then I try to find out, what is it I'm trying to do? Because, by the way, if you don't know what the problem is, then practically any solution will work. So then you do the analysis and the logical design, the physical design, implementation, and change. So it's one step after the other after the other. Rarely do you go back and revisit other phases. Only if there's a problem. Typically it just steps right on through. Okay, so the first one, the investigation. So what is the problem you're trying to solve? And you better have a good handle on this. I love another TV reference. Star Trek Voyager. That's ancient history, but they had a holographic doctor, and whenever they would, turn on the hologram for the doctor, he would magically appear and say, "Please state the nature of the medical emergency." That means, what is the problem? And if you cannot articulate the problem, well, our customers aren't really happy. I'm sorry, I need more than that. I can't design something based upon that. You're going to have to tell me what's wrong before I can do something. Okay. Here's another crazy story. Sometimes people get the idea, but they don't ever do any analysis. They go, oh, that must be the problem. Let's go headlong into solving it. And this is a stupid story, but just by the way. So somebody, is operating a grocery store, and the customers aren't really coming in much. And so they're losing sales. And so they asked, one little old lady, say, "Hey, we haven't seen you in a while. What's the reason?" And little old lady says, "Well, a lot of the products that I want are way up on top of the shelves, and there's nobody around to help, so I just can't reach those top shelves." And the guy says, "Oh, okay." So he's in his mind, he's thinking that's the problem that needs to be solved. Now you could do that by hiring more people, but he goes, "No, that's going to be kind of expensive in the long term. I tell you what, we're going to shut the store down, and we're going to rearrange all the shelves and make them shorter." And so that's what they did. They shut down an entire weekend, redid everything, brought everything back up, and it didn't improve sales at all. Why? Because a sample size of 1 is not sufficient to identify the problem. It was something else. You don't go off half-cocked and say, "This is it, we've got it." Oh, man. So the investigation phase, here, the process, outcome, goals, scope, cost, benefits, budget, constraints, et cetera, et cetera, et cetera. But it's really about, can you define the problem? Okay, the analysis part. The analysis part is, what are the requirements for us? Now that I know what the problem is, what are the requirements for the solution? That sounds kind of simple. And it could be something as simple as, has anyone else had the exact same problem? And if so, how did they solve it? Okay? So issues with the current program, environment, and requirements for the new one. Okay, the logical design basically is what needs to be done. Well, let's see, we need to do this, and then we need to do that, and then we, list all the things that need to be done. And you got to remember, business needs first. You can't just go off and in your logical design and say, well, we're going to turn this off and we're going to turn that on. It's like, no. We need to talk about, we have an overlap here and that kind of stuff. And then the physical design. Physical design is when you say, okay, now, we've talked about we need an ID system and we need 14 sensors. And so somebody has to sit down and say, okay, here's the brand we're going to get. Here's how much they cost. Here's what it's going to be for installation. Somebody has to go through the math. Now that you've given them a logical design, now I need a physical design to go with it that says, okay, here's what we're going to do. And here's where you decide whether or not you're going to build something in-house. Build or buy decision happens here. Because sometimes you might want to say, oh, look, I'm not going to have my guys go up on the ladder and install IDs. We're going to contract this whole thing out, the whole shebang. Or, the opposite. And then implementation, which means, okay, now it's time to do it. Either you or somebody else. This is where, the build or buy decision has been made. And then so install and test. You can't just install stuff and walk off, right? Yeah, test it. And this is where the initial user training takes place. You may have like a technician or maybe a whole group of folks. Okay, here's how you operate this thing. Here's how you monitor this thing. Here's how you respond to it. If it's like a database, I'm just making that as an example. Somebody's going to have to know how to operate the database and do backups and all the rest of that stuff. And then maintenance and change. Now, you might think the investigation probably won't take very long. It depends on the scope of the project. It could be a week. Analysis, maybe another week. Logical design, okay, maybe 2 weeks. Physical design, that's not that bad. Implementation, well, it depends on the scope. But maintenance and change happens forever, okay? Here's where you put your costing for the people who have to operate the system. Okay, so this is operation. I get a new employee, I got to train them on this thing. I have to have a help desk kind of a thing. Somebody calls up and said, I'm having trouble with this. And you go, bug fixes, change requests, upgrades. And so typically maintenance is the most expensive of all these things because the first handful, the first 4, are temporary. But change sticks around forever until you retire the system. So it's typically the most expensive. Okay, so let's kind of recap this thing. What is the problem? What are the requirements? What are my tasks? Do it and keep it running. All right? Okay, good. By the way, so this is not specific to the security world, right? I'm trying to build a house, right? Same old. Okay, so changing topics a little bit. Page 421 is software assurance. So the idea is I should write software that basically is free of bugs and secure by default. Oh boy, wouldn't that be nice? Is that a pipe dream? No, but there is a philosophy behind it that can get you really, really close. So bottom line is you got to build security in the product, while you're doing the logical design and the physical design. You can't get all the way down to implementation and go, oh yeah, we're going to need a retinal scanner at the server room. And you go, oh man, because that's going to make you go all the way back to logical design and pick out a vendor, figure out the cost, and figure out who's going to install it, the whole shebang. So the idea is that, if I'm using, Microsoft Word or Excel, right? Is there built-in security features for those applications? I mean, did Microsoft go in and say, for Excel, we will allow this and not allow this? You may have seen it before, like when you pull down a file off the internet and it says, no, you're not allowed to make any changes until you tell me this is good. So secure by default is the way of thinking. So now I'll confess, an awful lot of the details we're talking about here are not going to make any sense unless you're a developer, but that's okay. So we're going to move on. So the software design principles, there's basically a bullet list that say, okay, and this is good stuff. So economy of mechanism, basically the keep it simple thing. Keep the design as simple and small as possible. Don't start with a grandiose plan with 1,000 different moving parts. That's probably not the way to start any project at all, particularly a software project. Fail-safe defaults. If something is going to fail, make sure it fails in the right direction, either closing something down or whatever the scenario is. Okay, hey, we're coming up on the 15-minute mark. Doggone it.